So the shaded part is, for number 1, is this part right here. Whatever you want to call it, R, shaded part, that's it here. Okay, so what they're doing, what we're going to have to do is find the volume when squares are resting on top of that. Okay, so picture a square and it's resting on top of it, and each of the squares is perpendicular to the x-axis. So each square is standing a million squares going from, not even a million, probably an infinite number of squares because they're 2 dimensions, are going from this down to here. Okay, so that's the base of the square. And then the square is also coming out, same distance around. So it's a 3-dimensional shape. So it's similar to this one here. It'll be similar to this one, but instead of a half circle, they're squares. Okay, they're squares. So it's going to be similar to this. But instead of half circles, they're squares. Okay, that's what the shape's going to be. Okay, so kind of give you a visual of that. Right? Okay, so now we got to find the volume. So our formula says volume equals, we got an integral. We have to find the area of one of those cross sections. Well, we said it's a square, right? So what is area of a square? Yeah, just x squared, s squared, whatever you want to say, right? Because all the 4 sides are the same, so it's just going to be, so this each square,
I still have my phone.
okay. So each square will be here. That will go here. Okay, and it's coming out, there's a square here. Okay? Okay. So the area is one side squared, right? And is this going to be dx or dy? Dx, because it's perpendicular to the x-axis. Okay? So what would one side of the square be? It would go from the red to the green, right? All of them would go from the red to the green. So if I wanted to find that distance, I would find where the red is, and then I would find where the green is, and what would I do with those 2 numbers? Subtract them, right? Distance, you always subtract. Okay, so we're subtracting the red minus the green. Okay, so the red is y equals square root of x. Okay, y equals square root of x. The blue is y equals, or x equals 9, and then the green is y equals 0. So we're going to go red. One side would be red minus green. That's one side here. It's always going to change. It's never going to be the same number. All along, because remember, there are an infinite number of these orange dots along here, and an infinite number of orange dots along this. So it's never going to be the same number. But what it'll always be is red minus green. Okay? So red is the square root of x. So the square root of x minus the green, which is y equals 0. Dx. Okay? So the square root of x squared, the square root of x minus 0 is just the square root of x. Squared, which is just x. So really it's just x. This whole thing here simplifies to just be x. Okay, now the bounds. Well, since it's dx, we go left to right bound. So what x value marks the start of the shaded? 0. Which x value marks the end of the shade? 9. So it would be 0 to 9. Okay. So plug that into your calculator. And verify you get that. Okay. Again, x squared minus 0 is square root of x minus 0 is the square root of x. And then squared is just x. So really, to save yourself time, just put x instead of all that stuff. Okay, because that's really what it is. It's just x. All right. So now example number 2 is the same idea, except now we don't have squares. We have semicircles. So quickly redraw that picture on the second one, on example number 1B. On 1B, give yourself another picture that looks like, because all of the functions are the same. The only difference is it's semicircles. There we go. Still going to be the same shaded area. Still have y equals square root x, still have y equals 0, and still have y equals 9. So semicircles are half circles. Okay. So again, it's still perpendicular to x, right? X-axis. So that means this is going from from red, extending down to green. So this one's going to look exactly like the one on the front. This is going to look exactly like that. That's what that three-dimensional shape is going to look like. Okay. This is going to sit here and come out. So it'll be a half circle coming out. And there's an infinite number of half circles that are coming out to make that 3D shape. Okay? So we're going to need the area, because our formula says area of the cross-section. Well, the cross-section, if the cross-section is semicircles, what's the area of a semicircle? 1/2 pi r squared. Or pi r squared divided by 2. You can use either one. Either one's okay. 1/2 is probably better because we're going to have to do integration. But yeah, any of those would work. Okay. All right, so let's set up our equation. So we have, this is dx, we said, because it's perpendicular. That orange line is perpendicular to the x-axis. When it's perpendicular to the y, that's when it's going to be a dy. Okay? All right, so if this is always going to be the half circle, we know it's going to be 1/2 times pi. We're not going to use r because it's dx. So what would the radius be? It would be half of that, right? Because that represents the diameter. That's the diameter, right? This is the diameter. We don't want diameter. I want a radius, okay? So the diameter equals 2 radii, right? So if I solve for r equals 1/2 of a diameter, right? So what I'm going to do is I'm going to plug this in here. For r. Okay. What is the diameter going to be for those half circles? Root x minus 0, right? Minus 0, yeah. So it's going to be root x minus 0 divided by 2. Okay? Which is just root x, right? This is really just root x divided by 2, and if you square it, it would just be x over 4, right? Yeah, I'll simplify a little bit more. So you can say 1/2 times pi times x, not x squared, x over 4. Because root x minus 0 is root x. Root x over 2 squared, you square the top, you get x. You square the bottom, you get 4. And then you could even multiply that together. You could say x over 8. So x over 8. Then the bounds are the same as the last one because it's dx, so it's 0 to 8. So verify that you got 15.904. Okay. So that's kind of the wrench sometimes they'll throw in there, is that this isn't part of the formula, right? The orange dot to the orange dot isn't part of the formula. Oh, 0 to 9, sorry, it's supposed to be 0 to 9. Diameter means nothing when I'm trying to find area. Radius is everything. So you have to convert it. It's not a hard conversion, but you have to convert it there. So that's the tricky part sometimes. When they give you something and you don't need all of it, you need some of it, so you got to kind of convert it. Okay, that can be a little tricky sometimes. Okay. Okay, 1C is the same graph. So draw yourself a shade. Draw yourself a shaded region. Everything's the same. Square root x, x equals 9, x equals 0, or y equals 0, sorry. So this one's still perpendicular to the x. So that means whatever shape I have is still going to extend the same distance. Red to green. Okay. This one's an isosceles right triangle with the base as the leg of the triangle. Okay, so what's an isosceles triangle? I know it's a triangle, but what's special about an isosceles triangle?
Two sides are the same length.
Two sides are exactly the same length. So when two sides are exactly the same length, that means it's a 45, 45, 90 right triangle. Okay? So let me draw a quick picture. I always draw a quick picture of the cross section, just because it helps me with the area. Okay? So the two legs are exactly the same. So the two legs are exactly the same. One of them is going to be the base. It says the base is going to be one of them. So one of them is going to be either, it doesn't matter which one you choose, but because it's the same length. Okay. It's going to extend from dot to dot. Area of any triangle, right, is base times height divided by 2, or 1/2 base times height, whatever you want to write it. Okay. So before we can fill out our formula, we have to figure out what the base and what the height are going to be. Okay? We've got to figure out what the base and what the height are going to be. Okay, so it's 1/2 base times height. This one's also dx because we said it was with respect, or it's perpendicular to the x. Okay, 0 to 9 still, 0 to 9 because it's the same shaded area and it's still with respect to x, right? Okay, so here we go. The base is going to be from red dot to red dot. Or sorry, not red dot, orange dot to orange dot. Orange dot to orange dot. That's always going to be the base, right? So what is the distance from orange dot to orange dot? Square root of x minus 0, right? Square root of x minus 0. Okay. That's going to be the base. What is the height going to be? The same thing, right? Because it's an isosceles triangle. So whatever the base is, the height is also going to be the same. This side and this side are exactly the same. So it's going to be the square root of x minus 0. So both of those are just the square root of x. So the square root of x times the square root of x makes x. So it's really 1/2 x. All right. 20.25, verify that. Okay. Okay, so now example 2, they change what the graph's going to look like. So this picture is going to look a little different. So draw that picture. And we're going back to squares. X squared. Y equals 9. And that's it, right? All right, so this is the one we're going to use for the next 2 problems. So the bounded area, I'm going to use a lighter color. Is right there. Okay, so read this one if you haven't already. What's different? Or is there a different part?
Perpendicular to the y-axis now?
Yeah, perpendicular to the y. So that's going to be a dy. So we have a dy. We're still finding area. It's a square, right? We've done squares. Squares was x squared, right? Area of a square. All sides are the same. Okay. Good. Those squares are going to stand straight up, but they're not going to go this way anymore vertically. They're going to be horizontally, okay, across the light blue area. So they're going to go from, extend from this side to this side, and it looks like they're going to extend to the same function. Okay? So we got area equals x squared. Okay, so we know, let's see, volume equals, we know it's going to be x squared dy. So we got to figure out what that, how to find that distance in here. Okay? The blue was y equals 9, and the red was y equals x squared, right? Well, y equals 9 is not going to really affect the area. It's all the parabola, because that's where the side goes from here to here. Okay? But if I go x squared minus x squared, wouldn't that be 0? What's wrong with this guy, though?
It's not in terms of y.
It's not in terms of y, right? So we got to change it in terms of y. How do you do that? Make it say x equals. We don't want it to say y equals. I want it to say x equals. So to solve for x, I take the square root of both sides. So I get x equals plus or minus square root y. It's the same graph, but in terms of, it's solved in terms of y instead of in terms of x. So we have a positive and a negative. So the positive side is when we have positive x values. That's over here. The negative side is when we have negative y values, or x values. So they're actually two different functions when you solve for x. Okay? So now we subtract them. We go right minus left. So right is square root y minus negative square root y. Right minus left. So now, instead of canceling each other out, it's actually doubling them. It's 2 of these guys. What are the bounds going to be? What's the lower bound and the upper bound going to be? So 0 to 9. Yeah, 0 to 9. Because we use the y values this time. The lowest y value for the blue, shaded blue, is 0. The highest y value for the shade is 9. So it'd be 0 to 9 again. Okay, if it was dx, we would go from this dot to this dot here, whatever that is, but it's not. So when you do that, you get a whole number, 162, right? You should get 162. Okay. Oh, we got plenty of time. Okay, so I'm going to do number 2 with you guys. Then I'll let you guys do number 3 on your own. The last question, it doesn't have a number, it just says example. The last question was a free response question that I used to use on this test. When we took this test, it was an old question. It's a really good question, but I just used it too many times. So that's why I put it on there, because it's a good, it's a really good question from this section, because this section you see a lot of on free response questions. Okay. All right, so example number 2B now. So now we're going back to semicircles. It's the same graph, same 2 functions. We've done semicircles before. Okay. Let's see. There we go. Shaded region is here. All right. We still have, so is this dx or dy? Or is this dx or dy? It's going to be a dy again because perpendicular to the y-axis, yeah. So when I write this, this is y equals 9. And then when I write this, I'm going to write it as x equals again, because it's dy. Area of semicircles is 1/2 base, or not base, 1/2 pi r squared. Okay. So our volume formula needs to have a 1/2, needs to have a pi, and it needs to have an r squared. Okay. Those semicircles are going to extend from perpendicular to the y-axis, from there to there. Okay, so let's set up our volume. So again, I need a 1/2, I need a pi, and I need an r squared, and it's dy. Well, I don't have an r. I have a d, right? I have a diameter. So I have a diameter. Okay, so kind of like we did earlier on example number 1, we have to kind of manipulate that a little bit, right? So this guy here is going to be, what is r equal to? What is r the same as, we said? 1/2 d, right? 1/2 d. Or d over 2. So that we're going to put in here. So it's going to be 1/2 times the diameter. What's the diameter? It's going to be dot to dot. So positive square root y minus a negative square root y. It's going to extend to there. Let's see, square root y minus negative square root y. So it'd be plus plus. So in other words, 2 square root y. So when you crunch these numbers, you get this. Okay. All right, the next one, they give you a picture, so you don't have to draw it. So I want you to do number 3. Yeah, do number 3. We'll go over it, and we'll be done for today. And then tomorrow, I'll give you the practice for this. So if you haven't, I posted the updated calendar. So tomorrow, we'll finish the last problem. We'll work on the practice. Next week, we have a test, our last individual test. It'll be on this short chapter. So the individual test is going to be 1 day instead of 2, because it's just half a chapter. So we'll talk about that next week. But Monday, we're going to have like a kind of a review day. I'll give you the review. You can work on your practices. And then Tuesday, we'll do a review day. And then Wednesday, we'll have the test, our last test, our last individual test.
For why? Well, you gotta source the words. Again, bro. No, oh. Well, I can prove to you, don't worry. Well, I'll be.
So yeah, so this one's a dx, so it's with respect to x because it's perpendicular to the x-axis. Okay, so it's a square again. So square means all sides are the same, so find one and square the sides. So this one side is going to go from green dot to green dot. So you're going to subtract them. So it's going to be x minus a negative x, right?
Yep.
Which is another way of saying 2x. 2x squared, which is 4x squared. The bounds, because it's dx, go from left to right. So x equals 0 to x equals 4. 0 to 4. So 0 to 4, 2x squared dx, or 4x squared. And you get 85 and a third, 85.33333333. Okay. All right, so we got about 8 minutes or so. I don't want to go on to the next problem because the last problem I kind of want to do together. It won't take us very long, but it's a great problem because, like I said, it's a free response problem I used to use on the past tests.